Very good morning from Jalandhar, and I thank you to the organizers for inviting me. So, without wasting the time, let me. Uh,
Give 2 minutes,
Wait,
sir,
wait.
to introduce
Actually,
Sanjay sir.
Dr. Sanjay, I think there is no need. It will take myself to explain
Okay, sir.
myself
Okay. Okay, sir. You
because
start.
it will save my time.
Okay, sir. Okay, sir.
Very good morning to all who are connected here. I'm Dr. Anupam Yadav. I'm working as an associate professor at Dr. B.R. Ambedkar, National Institute of Technology, Jalandhar. And I work in the area of evolutionary computation, soft computing, and deep learning. And now I'll quickly move to the main context of this particular session. So in this session, we are going to see mathematical framework of deep learning from the perspective of how actually it works. Because if you see any user which uses deep learning or neural network or any type of neural network, so basically what happens, they use it as a toolbox. So they have some data, they process in the neural network and they get the kind of output. But through this particular session, what we'll try to do, we'll try to analyze how actually that neural network develops itself, how it evolves, what are the hidden layers, how can we control the number of hidden layers, what are the nodes, how can we control the nodes, and how the many features in the deep learning or very specifically in the artificial neural network, how can we control each one of them. So if you carefully follow this particular session, at least you will be able to analyze and understand any kind of neural network you are using. Then you will be able to visualize what actually happening inside when the model is being trained or network is working or network is being developed. So if I quickly move ahead, so basically this is the classification because the kind of thing we are discussing, it comes under the framework of artificial intelligence. So artificial intelligence is like any technique which tries or mimics the human brain. It is called an artificial intelligence. We should be able to differentiate between what is human intelligence or natural intelligence and what is the artificial intelligence. So if I take an example of a car driving. So if you, I often take this example to my students also to differentiate how one can understand what is the human intelligence and what is the artificial intelligence. So suppose you wanted to drive a particular car, and so what you need to do, you need to learn the driving. So recall your first day, those who are a very good driver at moment. Recall your first day. Someone must have taught you this is the brake, this is the clutch, or whatever the type of car, the basic requirement you must understand from some instructor. And then you try to drive it, and it you might have observed that at the first session or second or third session, the driving efficiency would not be as good as it is as of now to do when you are a very good driver. So if you carefully observe this entire learning procedure, so what is happening, you are trying to learn a particular thing for which you are gradually increasing your efficiency. But if you carefully observe that at no point of time you measure what would be the angle, what would be the speed of the car in very precise measurement, because you adapt each and everything, how much accelerator you need to press, you never measure it as a quantity. And but gradually over the time you learn all those things and you can smoothly drive. So this is a human intelligence where you learn certain thing and you are able to execute and you gradually improve yourself to do a particular task in a very efficient way. At the same time, if the same task is being asked for a machine to do, then what you need to do, you need to you need to train that machine also. For training that machine, you require certain kind of training model, certain kind of data which will be as an input for that machine to learn. So this is a very good example where one can understand how human intelligence is different from artificial intelligence. Then machine learning is basically a subset of AI which uses statistical methods to accomplish the similar tasks. And further, deep learning is a further subset of machine learning which uses the multi-layered neural networks for the computation. So whenever you hear or listen about the word deep learning, so it means we are going to do certain training of a model using artificial neural networks. And one more thing I would like to quote here. These definitions are very temporary because the technology changes very quickly. So what we are defining something in AI today, in coming days or coming weeks or coming years, the total context of that definition may be changed. But as of now, this is how we classify AI, ML, and deep learning. So this is again a framework of machine learning where we utilize the data, and basically we are classifying what type of machine learning algorithms could be, and it basically requires training and then followed by prediction. And then there are certain kind of learnings which are used to accomplish or train the model to get the desired model which are going to mimic as a human brain, or which is going to make the decision instead of a real human. So supervised learning is one of the type, unsupervised learning is another type, reinforcement learning is another type. Reinforcement learning is quite a new concept in comparison to supervised and unsupervised learning. So in supervised learning, we need a labeled data set. In unsupervised learning, if there is unlabeled data set, then it would be a right choice. And reinforcement learning is something like where you do the experiment, learn from it, reward the good performance and punish the bad performance, and keep that information with you and move further to develop a better model. So in supervised learning, basically, these are two examples where regression is a model which tries to develop a, it's like interpolation, where you are trying to interpolate any given set of data by using any polynomial function. And classification is a methodology where we try to classify the data in certain types or certain categories. Unsupervised learning is basically people use when the data is not very much organized, means its labeling is not done in a good way. So unsupervised learning we can do. It's basically a type of training model which can be useful for building a good model. And reinforcement learning, as I already told you, it's a kind of new one where you observe and take action after getting reward and penalty based on what kind of experience you are having. So this is how you can classify the difference, means compare the machine learning versus deep learning. In machine learning, for example, suppose there is a car and the objective is you wanted to develop a model which can classify whether the given object is a car or not. Particularly, suppose there's an image and you wanted to develop a model. When you pass that image into that model, it should yield and return that whether it's a car or not. So if you follow the basic machine learning, so what it does, it extracts the feature, then do the classification, and based on the classification it returns the output, whether it is A or it is B. In deep learning, the feature extraction is not required. It is altogether combined in a single one, and it does by creating a multi-layered neural network model, and which also does the same thing of the classification, whether it's a type A category data or type B category data. So that was very few basic fundamentals and concepts of AI, ML, or deep learning. Now I'll come to the main point which I wanted to explain in this particular session. Mathematics behind deep learning means we'll try to understand what is the core mathematical concept which works when you are developing a neural network model, or you are training a model using artificial neural network. So I'll begin with a very simple example of classification problem. Classification problem is a problem where we wanted to classify any given data into certain categories. So if I narrow down this concept to a more localized one, so that a beginner or a person who is trying to learn the concept of deep learning, he or she can understand it easily. Suppose this type of data is given to us, and it's a land fertility data, where circle represents the fertile land and crosses represent the infertile land. So basically there are two types of data: fertile land category A and infertile land category B. And this is kind of survey which is done by someone, or this kind of data is available in certain region, that these are the locations where the soil is fertile and these are the location where the soil is unfertile. Based on this data, we wanted to know more about this soil fertility or infertility where the data is not available. For example, if I choose this particular location, I don't have data, but what I want to do with this data, I wanted to develop a model which can tell that this particular, if I pick a new piece of land, then it should tell whether that land is a fertile land or infertile land. So what are going to be the ingredients for developing this model? The available data of fertile soil and infertile soil. And with the help of this data, we are going to tell the fertility of the soil at those locations where data is directly not available. So this is the simple problem of classification, where the entire data set has to be classified into two categories: category A fertile and category B infertile. So what objectives we wanted to achieve from this data of given data of fertility and infertility in terms of soil? So we wanted to use this given data to identify the fertility of the land where data is not available. Mathematically, it is a problem of curve fitting, but it may not work if you directly use interpolation kind of technique, because it may be overfit, or it may not reflect the same thing which you want. So here what we aim to design a transformation which maps a location into a circle or a cross. So somehow if we can come up with a mathematical function which is going to take input the location of the land, and as an output what it is going to give us, it is going to map whether it's a category A data or it's a category B data. If we have that kind of transformation available with us, then we can efficiently tell by picking a particular piece of land whether the soil is fertile or infertile. So the problem turns out to be how to develop such a transformation. So there are many ways, but in this particular approach, what we are going to do, we are going to use artificial neural networks to develop such a transformation. So here comes the role of activation function. Activation function is basically a kind of decision maker function. Those who are aware with basics of artificial neural network, there are a class of activation functions, those are available, and the role and objective through those activation functions are different depending on what kind of objective you want to achieve. So if you are trying to classify, then this sigmoid function is one of the good choice for the activation function. So this the role of this activation function is basically to create that transformation so that we can design such a transformation or mapping efficiently. So what you can see in this slide, an example of activation function, which is a sigmoid function whose mathematical expression is 1 upon 1 plus negative exponential. There are several activation functions already there, but the way we will develop the transformation rule using this sigmoid function, we can do in the parallel way by using any other activation function available for the use. So this is the general nature of sigmoid function, and this is the very basic definition of sigmoid function or basic expression of sigmoid function. But we can enhance the definition of this sigmoid function by replacing this minus x only, because if you see this expression is 1 upon 1 plus exponential of minus 4x minus 5. I can write here ax plus b also. So this, what you can see here, is a very particular case of this what I'm writing as sigma ax plus b. So this is a general sigmoid function. What we see here, this is the case when we have taken a equal to 1, a equal to minus 1, and b equal to 0. But this is how we can design any class of sigmoid function by choosing a suitable value of a and b. How to choose those suitable values, that we'll see in the coming lectures, in the coming slides. So the activation function is with us. We have chosen it for this very specific purpose. Now let us see how we can use this activation function to develop or create the artificial neural networks. So here, let us try to understand what are the basic features in this activation function. X is the input. When I'm writing sigma ax plus b, so this x will act as input variable where we are going to take the input of those data values which are available as a data set. If I go back and take the example of same case which we are discussing, the fertility or infertility of a particular piece of land. So X is the data which stores the information about whether that particular piece of land is fertile or infertile. A and B are certain parameters. We call A as weight and B call bias. We'll see why we are calling it as a weight and we are B is calling as bias. And the determination of optimal values of A and B are the main important task which has to be done using any optimization algorithm. So optimization is also involved in this entire process. We'll see when it will come and play its role in the picture. But here we should clearly understand that there are certain variables and parameters which are involved, and it should be clear what is the role of particular variable or parameter. So X is input, A is weight, and B is bias. So let us generalize this concept. Instead of working on real numbers, we can work from m-dimensional vector space to m-dimensional vector space, and we can enhance this entire concept of sigma ax plus b from one component to multivariate component. So this is small x was like a single real number 1, 2, 3, 4. But this capital X, how we are presenting it here, it is basically a vector. It has m components. And W is a matrix now, and B is a bias vector. So this W will be called as a weight matrix and capital B will be called as a bias vector. So this is simply the generalization of these variables. X as an input vector, A turned out to be a weight matrix and B turned out to be a bias vector. So basically it's just a simple generalization where we replace the one-dimensional entities what we understood so far to m-dimensional space. This is just so that we should be able and we should be rich enough to deal with multiple number of features at the same time. So let us see some basic mathematics which works for creating this artificial neural network. So if you see this particular slide, so there is simple computation. W is a weight matrix, X is an input vector, and B is a bias vector. So let me take a simple example of 2 by 2 case. Means this X has two components and this W will be a matrix of size 2 by 2 and this B will be the vector of length 2. How the computation will perform inside the basically they are responsible for creating the artificial neural network. So Wx plus V we can simply write in a particular example. If I take a 2 by 2 case, so W is a 2 by 2 matrix, capital X is a input vector of size 2 and B is a bias vector of size 2, length 2. So it's a two-dimensional framework. I am just showing it here as an example so that we can understand how computation will be performed. So here, what are the known things in this entire computation? The known things are input vectors. What are input vectors? X1 and X2. From where they will come? They will come from the available data. And what are the unknown things? Unknown things are Wij and B1, B2, or in general, Bi. So let me see how this computation actually works. So if you multiply this entire expression W1, W1, W21, W22 with X1, X2 plus B1, B2. So this is how you will get a new vector of length 2. So when this entire computation will be completed, you will get W11 X1 plus W12 X2 plus B1, W21 X1 plus W22 X2 plus B2. And this was happened by simply finding the rule of matrix multiplication. So this was, as I already told you, this was a simple example where we tried to enhance this concept from a one-dimensional structure to multi-dimensional. And what I explained here as an example, it was a 2 by 2 case. But in general, we can do for n number of features also. Means what I mean to say here, not only up to X1 and X2, we can go X1, X2, X3, X4 up to Xn. And in that sense, the computation will remain same, but we will get this kind of feature or this kind of value in each and every row. So this summation over J, Wij, Xj plus Bi is nothing but the enhanced concept of these two entries. W11 X1 plus W12 X2 plus B1, W21 X1 plus W22 X2 plus B2. So here, one thing I also wanted to emphasize, because whenever you see any picture about neural networks, so you see this kind of diagram. From where this diagram has come, basically this diagram is the representation of how matrix multiplication has happened. And this is how these diagrams are created. So once these values are evaluated and calculated, what will happen? We are created the first neural network. So X11, X1, X2, they are updated by the values W11 X1 plus W12 X2 plus B1, W21 X1 plus W22 X2 plus B2. What we have to do now, we have to use the choose an activation function recursively on this Wx plus b for the computation of Wx plus b. I hope those who followed are able to understand what is Wx plus b. But once the Wx plus b is available with us, what we are going to do, we are going to sequentially pass this Wx plus b into our activation function. So if you carefully observe this entire expression, it represents nothing but the creation of neural networks. So its innermost entry, what it says, sigma of Wx plus b. So it is basically what we pass the value of Wx plus b into the activation function. And once you will pass it, you will get you will get some values, and whatever those values are achieved, again multiply with the updated weight matrix with the bias vector, which I am calling here W2 B2, and you will get again a value, again pass it into the activation function by using further created and evaluated weight matrix and bias vector, and sequentially keep on doing it. So what it will do, it will create a sequence of computation, and each level of computation is going to create a particular layer of neural networks. So this is the pictorial diagram which presents the computational representation of this expression. So this is input layer. Input layer means the input data, which is we are using directly from the available data with us. And what happened, we passed it to Wx plus b. So we got another values. This is the same structure what I showed you here. And once it is here, then it will be passed into the sigmoid function, which is the activation function we are using right now. And depending on the choice of the size of weight matrix, it is going to create that number of nodes in a particular layer. So if you carefully observe here, in the input layer, there are only 2 nodes. Nodes means features. And in the second layer, also it has 2 nodes. But in the third layer, it has a 3 nodes. So how come we got suddenly 3 nodes from 2 nodes? So it can be done by choosing a suitable size of weight matrix. Instead of choosing 2 by 2, if I choose the matrix of size 3 cross 2, so what will happen? It will generate a vector of size 3. And once the size 3 vector will be created, then there will be 3 features or 3 nodes. And recursively, we keep on creating these networks. It will comprise layers and the nodes. How many numbers of layers and nodes are required for training a particular model? It's totally user's choice. And the number of times you are using the activation function, it will tell us how many layers are created. And the number of times you are changing the size of the weight matrix, it will determine how many times you are changing the number of nodes in a particular layer. So this is how the entire framework of artificial neural network develops and progresses towards the final layer. Final layer means the layer where we are stopping the recursive use of the activation function. So this was the basically theoretical concept where we did utilize the role of activation function and its recursive use to create the number of layers and specific number of nodes in a particular layer. So whenever you encounter with this question that I'm training a artificial neural network model where there are 100 hidden layers in that particular neural network. So whenever this terms comes out 100 hidden layers, it means what? Mathematically what it does, it says that 100 times the activation function is used to train that particular model. And if I say there are 5 nodes in a particular layer, so it means what? I have used a suitable weight matrix which is creating 5 nodes in a particular layer. So this was a simple simplification and elaboration of how the layers are created in a particular artificial neural network and the number of nodes in a specific layer. So this most of the people use artificial neural network, but they are unaware that how actually things happening inside the neural networks, what is the meaning of these arrows, and how the number of nodes are increasing and reducing. So I hope it may be clear now. So now again come to our original problem, which we took to understand this entire processing of developing artificial neural network model. So let us create a fitness function, because what information was with us? The information with us was the data of fertile and infertile land. Okay, so let me create a function y which maps like this: yxi equal to 1 if xi belongs to category A data, yxi equal to 0 if xi belongs to category B data. So what it means basically, it means that I took a piece of land means its location, and I passed this information into our function. If it is a fertile land, then this y should mark it as 1. If it is infertile land, then y should mark it as 0. Okay, so two types of functions are available here. One is this yxi, which we are using as a input data or input function value from the available data, and another one is capital fxi. Capital fxi is nothing but the complex function created by the recursive use of activation function, which you can see here. So if you recursively keep on using this activation function, so there it will create a very complex function which will involve weight matrices and the bias vectors. So if we are trying to mimic this capital Fx, and it should actually map the available input data of fertile and infertile land, so their difference must be 0. So to accomplish that, what we did here, we created a least square function, which is a difference of the available data and created function. And what we'll do, we will minimize it so that we can get the optimal values of the entries which are coming into the weight matrix and the bias vector. So this is basically an objective function now, which requires to be minimized. Its ideal minimum value is 0, and this yxi is known, and it is coming from the available data entries. This fxi is the value which is coming from the complex function created by artificial neural network. And in this fxi, there are several unknowns. What are those unknowns? Those unknowns are basically the entries in the weight matrix and the entries in the bias vector. So what we'll do, we will minimize this entire least square function for the minimum value of this function, and the variables which we need to evaluate here, they are the bias vectors and the weight, the components of weight matrix. So everything in this expression is known except weight matrices and the bias vector. These values are going to be determined by minimizing this function. So we'll choose the optimal values of weight matrices and the bias vector in such a way so that this function should be minimum. So for minimizing this function, there may be many techniques. Those like gradient descent, stochastic gradient descent, Adams optimizer, they are the popular technique in those who work in neural network area. They can be used to minimize this particular function. And once you will minimize, suppose I use the Adams optimizer, so it will minimize it and it will yield the values of weight matrices and the bias vector. And then everything will be known to us. And once weight matrix and bias are known to us, then this entire expression is explicitly known to us. There is nothing unknown except X. So it's like we interpolated the entire data with the help of artificial neural network, and we are having a good modeled function. Now what we need to do, we need to only pass the values of location or x, and it will return whether that piece of land is fertile or infertile. So once that capital Fx is with us, we can draw its a structure, and this function will classify that particular region, that this region is basically lying under the mapping of infertile land, and the another region is lying in the mapping of fertile land. So this is how a simple classification problem, where we wanted to classify a certain piece of land into fertile category and infertile category, and it was achieved by training a artificial neural network model where we use sigmoid activation function and the some available data of the fertility and infertility ideas of that piece of land. So this completes the entire modeling. So the main features which are important here, the choice of activation function, the training, and the minimization of the error function, which I also called as a fitness function. Then you can accomplish it. So if you go to next time in MATLAB or any other package where you are going to use some artificial neural network toolbox, so when you do some clicks and it will return you the result, then you should realize that these were the things which had happened inside that particular package, which you cannot see, but this is how it works. Now I told you certain types of activation functions. Based on the need and the specific problem, you can use different types of activation functions. Sigmoid function was one of the example which we took to understand that particular case study. But step function, ReLU, leaky ReLU, tan hyperbolic, Gaussian error linear unit, soft plus, exponential linear unit, scaled exponential linear unit, soft sine, square nonlinearity, bent identity, sigmoid linear unit, sinusoid, sinc, Gaussian, SQRBF. There are further few examples of activation functions. They are being used in a specific situations depending on what kind of data you are having, what kind of objective you are having, and what kind of classification you want to execute. Then there are numerous applications of this training of network using ANN, or in holistically we call it as a deep learning. So the applications are like in self-driving cars, automatic colorization of black and white images, automatic machine translation, object classification, which I already took a case study to explain the entire processing, automatic handwriting generation, automatic text generation, adding sounds to silent movies, automatic game playing, language translations, pixel restoration to improve the quality of an image, photo description, means you wanted to detect certain features in a photo or an image, new aggregation and fraud news detection, natural language processing, virtual assistants like Google Assistant. In entertainment industry, it is used, visual recognition, fraud detection, healthcare, detecting development delay in children growth, demographic and election prediction, deep dreaming. These are some areas, not the complete list is here. Some of the important areas where the deep learning is being used and utilized. Now, those wanted to really work on this deep learning framework. Now, I'd like to show you here certain important toolbox which are available in Python, which can be easily used to use and develop and train neural network models. So TensorFlow is a library. Those who are aware with the Python language, there is a good platform called Anaconda. You can download that place and the entire package, and it has many modules inside it. And there you can find the Jupyter notebook also. And these are the library which are, some of them are already included in the Anaconda, and some of them you can integrate with the Anaconda framework. So TensorFlow is a very rich library which provides very ready to use tools like handling deep neural networks. If you wanted to use some ideas and concepts using natural language processing, there are some tools available which can solve difficult partial differential equations. Abstraction capabilities are there. Image, text, and speech recognition can be implemented there very easily. And the entire user experience is very easy. Effortlessly, you can collaborate and share your code with that platform, so that if you wanted to work in a collaborative manner, the things can be done easily. And there are further more libraries like Keras. It has ready to use features like neural layers, several activation and cost functions. You can feed their objectives, batch normalization if you wanted to do some computation with the data. Dropout action and pooling action can be performed in Keras. Then scikit-learn is again a very useful library where you can do the actions like classification, regression, clustering, dimensionality reduction, model selection, pre-processing of the data very easy. Again, Spark mlib is again further a library. So these libraries are basically developed by different domains. So there are many features which are common to these libraries, like regression you can do with Spark mlib also, and in scikit-learn also. So regression, clustering, there are many optimization tools available in the Spark mlib. Dimensionality reduction you can do in the Spark mlib. Classification can also be done. Many statistical tools are ready to use available there. Feature extraction in image and text. The tools related to these activities you can find in the Spark mlib also. Now, these are the some some features you can do in the scikit-learn library. Like classification, it identify which category an object belongs to. It's a similar case what example we took to understand the working of artificial neural network. It has application in spam detection, image recognition, the ready-to-use algorithms which you can find in the scikit-learn for classification, SVM, nearest neighbor, random forest, and many more machine learning algorithms. And regression is also inbuilt there. Drug response, stock prices, prediction, it can be done using regression in the scikit-learn library. Again, SVR, nearest neighbor, random forest, they are ready to use in this particular module. Only you need to call it by using the specific keyword. Then clustering can also be done in the scikit-learn library. It's possible applications are customer segmentation, grouping, experiment outcomes. So k-means, spectral clustering, mean shift, these kind of algorithms you can easily access in this particular module. Then in dimensionality reduction can also be done in the scikit-learn library. This is required when you wanted to visualize the data. If it has multi-dimensional data, so it is not easy to visualize it. So dimensionality reduction then plays an important role to see its visuals. So again, K means feature selection, non-negative matrix factorization. These mathematical tools you can easily access in this particular dimensionality reduction feature of scikit-learn. Then model selection, grid search, cross validation, certain metrics you can access in the model selection module. Pre-processing can also be done in the in this scikit-learn platform. Transforming input data such as text for use with machine learning algorithms. It can be done to normalize or extract certain feature from any given data in this pre-processing model. So these were few examples, and I showed you some basic libraries of this Anaconda platform, basically scikit-learn library. So those who wanted to use it for their work, they should go to this Anaconda. So this is the web page of Anaconda. I hope you can see my screen. So you can download it. So once you will download it, let me see if Anaconda is in this system. Yes, it is already installed here. So once you will download this Anaconda framework to your system, then let me show you what kind of features you can access over there to deal and work with this machine learning activities. So it will take few moments to initiate this Anaconda framework. Then you will be able to see the features. So it's just loading all the applications. It is available for both Windows and Mac platform. It is taking long than I expected. Let us wait for a few moments more. Okay, in the meantime, I can take quick questions. When it starts, I'll come to this particular module. If there are any queries, any question regarding the artificial neural network or machine learning or deep learning, I'll be happy to answer. I'm just waiting for this module to be opened. There are some questions.
Participants, how
Okay.
scikit-learn works in a spam.
Okay, how scikit-learn works in spam detection. So it's like spam detection is basically one of the early examples of this classification problem, which was dealt by the Google itself for their Gmail. So scikit-learn is basically a platform or a library which provides you certain tools where you can train a model which can detect whether an incoming email is spam or not. So if you want to know how this entire framework work, I can briefly explain it. So in the early phase, when Google people started using this Gmail, so there were spam emails. So what Google does at that time, they gave an option to the user to mark whether an arrived email is an spam email or not. And also they pick certain features, certain properties of that email text to be classified as whether it's a spam or not. So over the years, by collecting this data, so that was the input data. Like I received an email, I read it and I marked that this email is an spam email. So that information was recorded in Google database. So this kind of database was created by hundreds and millions of users across the globe. And by using that data, they developed a model. What actually they, how they actually have accomplished, the Google only knows. But by utilizing that model itself, they, by utilizing that data itself, they created and trained a model which works like this. Whenever an email arrives for delivery, it passes through that particular model and immediately it classifies it, whether it's a spam email or non-spam email. And how it can be done in scikit-learn? Scikit-learn is not is not only limited to certain exercises. It is a rich and bigger platform. It basically provides those tools which are required to prepare this particular classification problem and execute. So this is how this spam detection scheme works. And of course, scikit-learn libraries, the tools in the scikit-learn could be helpful to develop such a model. So let me check if it opens. No, it's not open so far. Oh no, it is not in the backdrop also. Let me try one more time. Because this Anaconda is basically a very nice and complete package available open source for research. And okay, it is already running, it shows, but I cannot see it. Anyway, it's not opening. I don't know why it's not working here. But those who actually wanted to work, I showed you the link of the website. Just go there, download this code, install, and then you will be able to see the available features like Jupyter Notebook. And inside Jupyter Notebook, you can call all these libraries which I showed you, like scikit-learn, Keras, TensorFlow. So that was all from my end. If there are any questions, we can have it.
So one question is that what is the role of hypernet?
Sorry, your voice is breaking. No, I have the full volume.
Hyperparameters, sir.
Okay. Can you write in the chat box? Okay, hyperparameters. What one wants to know about hyperparameters?
That means optimizations of neural networks.
Hyperparameters in neural networks?
Yeah, right.
So as far as parameters are concerned in neural networks, so there are two types of parameter which comes. One is the bias vector and another one is the weight matrix. So they have to be determined while minimizing that least square function, which is a combination of input data and the modeled complex function using neural networks. These are the only hyperparameters in the neural networks. So basically, when you read any article or anything about artificial neural networks, so whenever they try to address that optimization of hyperparameters is required, so you should immediately connect that these are the hyperparameters. So if you are asking about role of the hyperparameters, so they play a very important role. So if I go back to this slide, this one. So if you carefully see, the hyperparameters are involved in this capital F. And what we wanted to know its minimum value, and its ideal minimum value is 0. So the determination of optimal values of hyperparameters are very essential, because then only your model will behave accurately. If you come up with the wrong hyperparameters or suboptimal hyperparameters, then the functioning of your model will not be as appropriate as you expect. So the role of hyperparameters are very important, because ultimately for classification, what we are using this capital Fx, and this capital Fx will be used to know the values of those locations or those data where information is not available. And inside this Fx, the hyperparameters are involved. If the right value of hyperparameters are not with us, then the conclusion made using capital Fx will also be not correct. So the role of hyperparameters are very important, and it has extreme importance, because their optimal values are directly related to the accuracy of your developed model. The more and better optimal values you will come up with the hyperparameters, the developed model will behave more appropriately in a more realistic way. So that is the basic role of hyperparameters.
Any query, participants? No queries. Okay. Hello, any query from participants? No. Thank you, sir. Thank you so much. This session was very fruitful and informative for our participants. And we will surely take your words into in exercise. And we have enclosed all important functions and mathematics behind deep learning, how it works. Once again, I would like to thank you from depth of my hearts for accepting my invitations. Looking forward for seeing you, sir. Thank you so much. For any query, hello, over to Vishal, sir.
Thank you very much. I really apologize for the delay, and actually it made the entire this session into a very running session other than like marathon. So I am thankful to the Amity and Dr. Sanjay, Dr. Lalita for inviting me to this particular program, and I'm sure the participants will have some insight from this session. And if you have further any queries, or you want to work on this particular framework, or you want to work in optimization, feel free to write me. My email ID is anupam@nitj.ac.in. I'll be happy to answer your queries and your problems if you face any.
Thank you very much, sir. Participants wants your PPT also. So
PPT, I'll share this PPT with Dr. Sanjay. You can circulate it with the participants.
okay. Thank you very much, sir, for a very nice and informative session.
Thank you. Thank you so much.
Okay. So, dear participants, we will have our next session at 2:30 p.m. So, till then, we will be taking a break of around 2 hours. Okay. So, see you at 2:30 p.m. Thank you.
Yes, sir. Good afternoon, sir. Sakya, sir, good afternoon.
Good afternoon, sir. Sir, can you hear us? Sakyajit, sir.
Sakya, sir, your voice is not coming. Kindly check, sir.
Sir, please inform him he have to connect his audio. He didn't connect his audio option.
Okay.
Now, sir, we will speak.
Good afternoon, sir.
Sir, unmute yourself. Sakya, sir, unmute yourself.
Yes,
Can you hear
yes,
me
sir.
now?
Now,
Yes, sir.
Okay.
Good afternoon, sir. Sir, please check your PPT. Please share your PPT and check whether it is moving or not.
Okay. So I'll share my presentation. Hello.
Sir, just test it. Check it, sir, whether it is working or not.
Okay.
Okay, sir.
Can you see my screen?
Yes, sir. It's visible.
And can you see this?
Yes, sir. No problem. Everything is fine, sir.
Okay.
Okay, sir. Give me 1 minute.
So shall I start?
No, sir. Just
Okay.
give me time. Okay. Ladies and gentlemen, esteemed participants and respected faculty members, good afternoon, you all. And it gives me immense pleasure to introduce our keynote speaker for this FDP session, Dr. Satyajit sir. Sir is a senior scientist at TCS Research with interest in human sensing for health, wellness, and behavior modeling. He has over 10 years of experience in corporate research and has led multiple projects involving designing mathematical algorithms in life science diagnostic system. Satya sir received his PhD in statistics from Trinity College, Dublin. He has 13 patents and over 30 papers published in peer-reviewed journals and top-tier conferences. His wealth of knowledge and contribution to the field make him a distinguished speaker. And we are fortunate to have him share his insights with us today. So without further delay, please join me in giving a warm welcome to Dr. Satyajit sir as he takes a stage to enlighten us with his valuable and you can say that the expertise and experiences. Thank you, sir, and over to you, sir.
Thank you. So hi everyone. Can you hear me all?
Yes, sir.
Yes, sir.
Okay. So as far as I remember, last year I also took a class here in Amity.
Yes, sir.
So yeah, so it's good to see you all again and
Same thing from this side, sir.
Sorry?
Same thing for our side, sir.
Yes, yes. So let me start. So today I will give you a short view on R programming and like how it works, what is R, and how to do some programming using R. And I'll give you some brief overview. So R is basically a statistical language. So it was developed in the end 80s or at the beginning of early 90s in order to have an open software that is that can be widely used as a statistical and data analysis tool. So why R? I mean, there were many languages and many softwares like C, C++, Java programming, everything. So R has the real beauty in the sense that R is completely open. Open software means not only it is free, but if you go to the R packages and R codes, then you can change them on your own. Like suppose you want to do regression and then you go to some R code for regression and then
Sir,
you,
sir,
yes,
sir, it keeps in a presentation mode, sir.
sorry.
Presentation mode, sir.
It's a presentation mode, sir.
So it is in presentation mode, right? Can you see it scrolling?
The scrolling is okay, but okay, sir, it's a PDF and okay.
I think F12, F12.
Sorry, I can't understand you.
Sir, we want to see your full screen, sir. The PPT is
Full
full
screen, sir.
screen. Yes, a slideshow type.
Uh, I can't
Actually, you are
see
doing
any
PDF.
slideshow here.
Okay, sir, no problem.
Can you see
Continue,
that?
sir. Yes,
Can
sir,
you
we
see?
can see. We can see, sir. Continue, sir.
Okay. So, so suppose what I was saying that you want to do some linear regression on a data set. So what you can do, you can go to R and there are many method commands for doing linear regression, and you can have one command, you call one command, and then you can show its, you can see its source code. So what the code, how it is coded, and then you can change the code by yourself to tune it for your own purpose. So that is one beauty of R that was missing in the all the other softwares. And R is widely, as it is written there, it is widely used as a statistical software and data analysis tool, and it is available across the all the platforms like Windows, Linux, Mac. uh, and though in Linux it is somewhat a bit difficult to use directly R, we have to download R Studio to do it. Anyway, so here can you see the picture, the R script, R environment, R console? Hello,
Yes, sir.
can you see the picture? The under the brief overview, there is a picture
Yes,
of
sir.
the
No,
entire R
no,
console.
sir. No, no, sir. Actually, you have to minimize your screen, sir. Then only we can see.
I have to minimize my screen.
Sorry, maximize, sir. Maximize, sir. Maximize, sir. Actually, you are doing on Linux, sir.
Yes, I'm doing on Linux, but the
Yes,
problem is
sir.
that,
Maximize, sir. Maximize button. You can maximize your screen, sir. I think
but
F10,
it is
F10, sir, na?
completely maximized. It is fully maximized.
Okay. Okay, okay.
I don't know what else to do.
Don't do anything, sir. It's very fine. Now
But can you
simply
see the
just
screen?
continue. Yes, sir. We can see a screen. The thing is that the some like R script you have written, R environment you have written,
Right.
and in here some small codes, snapshot of a code is there. So actually, it's not properly. We cannot see, sir. Main thing is that. So if you are doing in this here, no doubt, no issue, sir. You can continue.
So shall I
Just
stop
explain,
sharing
sir.
once?
Yes. Shall stop sharing means then what you will do?
Then I will share it again if it is of any help.
Sir, try. Just no issue. Try
Okay,
it, sir.
let me try it.
Okay, sir. Sir, it is written that you are maximize 76%, and I think she wants Monica Patak.
Where
She
is it
wrote that
written?
and do it 100% in chat. She has written. I think that the size of this she want to say that the PPT size is 76%.
Okay,
And
let
if
me
you
see.
okay. Yes.
Can you?
Yes.
Is it
Yes.
visible now?
Yes. It is visible, sir.
Okay. So in an R studio or in an R console, there are mainly 4 parts. So one is R script, where you write your codes. One is the R console. So when you run your code, then in this console, in the lower part, it gives the results. And in the right hand side, in the upper right hand side, there is R environment. R environment, it shows like what vectors you have used, what objects you have used, what data you have used for your data analysis. And then the last one is the graphical output. So suppose you do some plots in R to see how your data behaves, then the plots are are shown in this section, the left hand corner, sorry, the right hand corner. So the main part, the main 2 sections for our use are the left hand corners, the R script and R console. So in the R script, when you open an R studio, these 2 things come. So one is R script, where you write your code like 2 plus 2, and then you run that code 2 plus 2, and then in the R console it will come as 4. So that is how R works. And this is the application of,
Sir,
yes,
Sakya sir,
yes,
Sakya sir, in this side there it is like short form of our slide is
Your slides.
visible. So here the last one icon is there. Well, just click here, and you will see the in a full mode.
sorry, I do not understand what.
Sir, sir, the slide is there, okay, and number of slide like 1 2 3 4 5, it is shown in left side.
Mm-hmm.
Is it fine, sir? Here,
Yes.
yes, just
Okay.
last one, the thumbnails just below the thumbnails, just yes, the yes.
So is it fine
Double click on here, then it will
here?
yes, sir.
Not this, but you want this. You want to.
Problem is same, sir. Okay, sir, please continue, sir. And
Okay, another thing that I can do, that I sent you the slides. If you can see in WhatsApp. So
Okay, sir. We can also, yes, we can also share.
so you can present from your side, and you can do the slideshow from your side, and I will do the explanation.
Okay. Okay,
Can
sir.
it be
No
done?
issue. Yes, sir. It can be.
Then please do it, and I stop sharing my screen.
Okay, sir. Where you will share, sir?
In WhatsApp.
In WhatsApp. Okay.
let's you. Hello, sir.
Yes.
Sir, we have checked, and if you click on the three dots on the left corner of your presentation, then it will be in full mode. Yes, like this R1.pdf. Just
Okay, I
do click.
sent Miss Lalita Kumari the slide so she can present from her side, and I can, if it is okay.
Uh, Sir, it will be okay, but sir,
Or tell me
can
what
you,
what can
yes,
I do?
sir, yes, can you please, sir, you try on this three.
Go to mute and look. Unmute.
Yes,
Mute.
Let me check.
yes, sir.
Okay, okay, okay. I got it. Got it.
Yes, sir.
Now check.
Yes, sir. Please.
Is it okay now?
Yes, sir. Now it is okay. Thank you, sir.
Is it fine?
ये भी mute हो गया ना मेरा आवाज नहीं जा रहा उनको भी नहीं आ रहा है
Yes, sir. It looks fine. Now you just in the full mode. You can start, sir.
Hello, I can't hear you. Is it fine now?
Sir, actually, again, it is not in full mode. Here, R1.pdf, it is written where
Ma'am,
three
sir have
line.
ma'am, sir is sharing from phone device. It's better if you are shared.
Okay,
It's
sir.
better you
I'll
share
share.
from your end. Ma'am,
Okay,
sir is sharing
Yes,
from
it is
phone
better
no
you
device,
issue.
share from your end.
and there is not a good connection, internet
Okay.
connection. That's why it's not coming as clear.
Okay, 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 no problem. No problem, no issue. I'll share.
Ma'am, press F11 your system. Press F11.
mute हो गया ना अभी तो ठीक है लेकिन मेरा वॉइस जा रहा है
Sir, hello.
Yes. Yes, tell me.
Sir, if you feel that if I'm sharing, then you are comfortable, then it's okay. Otherwise, you can also share that,
No, no,
that
no.
previously
I'm
you have shared.
comfortable with your
No
sharing.
issue. Okay, sir. So right now it's a correct page, sir, or I have
Okay,
to
so
go down.
let us go to slide 3.
Slide number 3. Okay, sir.
Yeah.
Application of R programming.
Yeah.
Ji, sir.
So there are different applications of R programming. So one is academics, one is healthcare, and there is retail, then there is insurance. Like I am giving you some examples. I work in healthcare in R. So how R is used in healthcare? Like suppose one general problem is that in healthcare we need to predict some disease in a patient. So there are a large number of subjects like 1000 or 1500 patients, and some of them suppose have grown a certain kind of heart disease and some of them did not have it. So how will we and we have their information like vitals, we have their information like lab values, the demography, their different history, everything. So the question is, by looking at these vitals and lab values and etc., how can we decide that certain patient will have the this disease and certain patient will not have that disease. So here R has a huge um, use, because in R what we can do, R can handle the big data well, first thing. Secondly, there are lots of packages in R by which, using which we can build different statistical algorithms. And third, by running R will not take much time. It is very fast, unless it is a very big data, like data in terabytes. Then it is a problem, but that is a problem with all softwares. Otherwise, R runs very fast. So there are, R can handle big data. R can, R has lots of, like, thousands and millions of packages using which we can build any statistical algorithms. And third, R, uh, R can, R takes not much time to run. So the usage, the resource and the complexity is low. So that is one example in healthcare. Another example is in, say, insurance. So nowadays, in insurance, one of the main concerns is fraud, insurance fraud. Many people use false forms, false applications, and they claim money. So how to catch these frauds, these insurance frauds? So to do that, R has a vast use, because they're also, by looking at lots of applications and the customer behaviors, R can do what? R can find the patterns behind the genuine customers and the fraud customers. R can distinguish the pattern. So there are different, again, different programs in R by which it can do it. And also it has similarly used in finance, media, manufacturing, everywhere. So I will give some example how it is used at the end of my talk. So can we go to the next slide, please? So why R language? So one is the free installation. R is completely free. Second is a vast community. So vast community means if you check in Google, then you will find there are lots of R communities where you can find many answers. Suppose you are stuck in coding in a certain aspect, then in those R communities, if you ask those questions like how will I solve the problem, then some instant answers can be found. And there are lots of R communities, and they are growing. And it is platform independent. Platform independent means R can be used likewise in Windows, Linux, and Mac, and everywhere. And there are latest technologies, and R can integrate with other languages. Why, how? Like, there are many R programs that can be called from C or C++. And similarly, Python is another language that are being used a lot, and many R programs can be called via Python, and many Python programs can be called via R, and they have some interdependencies also. So suppose you want to work in Python, but there are some coding that you find that you can, it is better to code in R, because it is easier to code in R, as in most of the cases R is easier than Python. Then you can code in R, and then you can call the function from Python. It is not difficult. So these are the main advantages of R. The main advantage is obviously it is open software, completely open. So it is free, and you can edit the codes and you can tune the codes for your own purpose. The next slide, please. And here are the pros and cons of R that I'll go through it quickly before going to the R commands and how it works. So the advantage is, as I said, open source. Then lots of packages, array of packages. I mean, there are like, it is growing, but right now it is more than 100,000 packages in R that you can use. Then the plotting and graphing, they are very good, very, I mean, visually they are beautiful. and it is platform independent, as I have said. And there R is used for machine learning of most of the machine learning operations like statistics, time series analysis, classification, regression, clustering. Everywhere R is used to solve different problems, as I have mentioned, in healthcare, in insurance, in transportation, and it is obviously continuously growing. It is since relatively new, so lots of packages are coming every day. Every day we see on a certain subject multiple number of packages. The disadvantage is data handling. The first disadvantage is data handling in the sense, suppose the data is in terabyte, then R has some problem, R becomes very slow. And then there is a basic security problem, because since it is an open software, so there is no right, I mean there is no copyright. Suppose you write a code and then you use that code and you put that code in our repository, then there is no guarantee that your code will not be used by some other persons, because it is completely open. And that is why there are some companies there who has some concern over these copyrights and brands. They do not want to use R because of this openness. And there's some languages are complicated, as you will see while using R. And obviously lesser speed in the sense that if it is a big data, then Python works faster than R. But still I would recommend you to use R over Python, because in real life, when you go to some data analysis, you will see that big data does not usually come. I mean, a very big data, it is, I mean, they can be handled if they come. The main problem is not with the big data. The main problem is with the small data nowadays, because there are lots of data. You can use it many times. But if there is small data, very small data, as you will also see that there are many occasions that there where you will not have data, much data, then how will you solve the problem? That is a growing challenge nowadays. So as we say, that big data is not the problem. The problem is small data. And in small data operations, R is the master. I mean, no one can beat R. Next slide, please. Okay, so now as I am telling you that there are R packages. So what are those packages? So the package means mainly softwares. So suppose you will solve a, I will show it in an example also. But suppose you will solve a problem like a linear regression on a data set. So to do a linear regression, you see that this data set needs to be first cleaned, because there are lots of noises in the data set, lots of outliers and lots of abnormal observations. Then what will you do? So you have to clean the data. To clean the data, suppose you do not have that, you do not know how to clean the data. So what you do, you go to the R community, you ask them, like, I want to I have this and this data and I want to clean it, these are the problems, how will you do it? And they will tell you some packages. Okay, you install this package, and the after installing this package, when you run the codes, run the package, then um, the data will be cleaned. So what will you do? You will check available R packages, like whether this package X, say for example, is present at in your number of installed packages. If not, if no, then you can install the package from the CRAN. We call it CRAN. So it is the R depository. So all the packages, all these millions of packages, they are saved in CRAN. So you can install the package from CRAN very easily. Just go to Google and just give the command install package X, install R package X, and then the installation will come. Or you can install from the R console itself, like the R director, R console that I showed you in slide number 2 or slide number 3. There is one option for installing packages. You can install the packages from there. And then to run the package, you have to load this package to your console. Like, you have installed the package, okay, and it is just any program in your computer. Like, you have installed the program, but maybe you did not run it. So to make the program usable, you have to run that program. Here also, to make the package usable, you have to load that package. After loading that package, you just run the command like clean dot data something of our given data, and then this data set is cleaned. Similarly, for say feature reduction, so you install another package. Say there is one package called mass, MASS, and there there are lots of feature reduction techniques, and you load this package mass, and then load this package means there is this command load, LOAD. So load, then package name, load bracket package name, and this package will be loaded in your R console, and then you run this package, and you feed your data to that package, and it will give you a data with reduced feature set. So and I will show you in the next slide some known R, some very popular and known R packages. So can you please go to the next slide? So these are the instances of some known R packages. So R provides library function which allows us to get the list of all the installed packages. So in the R console, there is one option called library. If you click on library, you will see that say suppose these are the packages, and in the right hand side some short examples of short descriptions of these packages are written. So base is the R base package. By installing base, what you can do, you can load the data, you can read the data, you can save your work, or you can do some very basic commands like summation, multiplication, division, all these things by this base package. Then there is a boot package where it used to do bootstraps the functions. Then there is a package class where it does functions for classification. So classification means suppose again we have two sets of patients, one having a heart disease and another set does not have that heart disease. So when a new patient comes, which class should the patient belong to? So to do that, we need to do classification, like assign the patient to a certain class. And to do that, we need to do classification. And to do classification, we need to use this package class, because there are some classifiers, some very well-known classifiers are there, like k nearest neighborhood, or classifiers like naive Bayes, or classifiers like logistic regression. These classifiers are in this package class. Then there is a cluster. So what is cluster package? Suppose there are a group of patients, and we do not know whether which patient has which disease, but we suspect that some patients are not well and some patients are well. I mean, some patients are ready to be discharged from hospital and some patients are not ready to be discharged, but we do not know which one is which. So what we can do, we can cluster the patients, like we can divide the patients in different subgroups, and so that suppose we divide the patients in two subgroups, so that within each subgroups the patient set is homogeneous, and between the subgroups there are differences between the patients, differences in the patients. So this is done by cluster, this package cluster. So cluster, in this package there are different clustering techniques like k-means clustering, and like the Gaussian mixture model clustering, hierarchical clustering. There are many clustering methods are there in this package cluster. And by this way, all the package runs. Like there are this package called very important and very popular package that is called mass. In this package, this generally is generally used for classification, and there are lots of classifiers are there in this package, like SVM or random forest, and different classifiers. And this mass package is also used to reduce the data set, like the data is massive in volume, and then we want to reduce the data by its features, or we want to reduce the number of observations, so that we can take a small sample of the data, which is the representative of the full data. How to do it? There are many commands in mass that which helps us to do it. So I would suggest you to go to Google and say, suppose you type R package mass, then it will give you a PDF. In the PDF, within that package, there are lots of commands. Like one command is mass, one command might be SVM. So there are lots of commands, and you go to each command and you see how they work and what purpose they are used for. Like what purpose is the command mass used? What purpose is the command, say for example, SVM used? How is SVM used? What is the main principles behind SVM? All the SVM means support vector machine, that is a classifier. And there is also one package called SVM itself, which has all the variants of support vector machines and its uses. So you can type the package rsvm, and it will give you the entire package and the entire PDF. And within this PDF, you have different commands, and you can have an idea how these commands work. And by that, you can learn how R works by doing that. So can we go to the next slide, please? Yeah, there are also some of the popular R packages that I told you. One is ggplot2. ggplot2 is used many times, and as you can understand from the name, that it is used for plotting. So plotting two-dimensional pictures or plotting three-dimensional graphs, ggplot is a very good package. And also they are also under ggplot2, you will get a lots of commands and lots of codes which are used to do different kinds of plottings. Like one plot is might be histogram, another plot might be some line diagrams or some bar diagrams, and everything that is taken care by ggplot2 and gggraph. Similarly, there is this package mass, and there is this package E1071. E1071 is also a classification package, and this is you. And generally, we use support vector machine by taking the SVM from this package. So in under E1071, there are lots of techniques to say clean the data for before classification, to run the classifiers like SVM before classification, and uh, um, to reduce the, to do a feature reduction on the data by using some known feature reduction techniques and some information some information related procedure. These are all taken care by E1071. And obviously there are other packages also which do the same thing, but yes, E1071 is very popular in for our work, because it has this SVM, the support vector machine, and other classifiers which work very fast. And that is why E1071 is very popular in our field. I also work a lot of time with E1071. Next slide, please.
Oh, sir, just one question, sir. E107 is used to feature selection, sir.
Mainly classification.
Okay,
And
for classify the
using that,
data.
yes, because the support vector machines, the SVM, and all its derivatives, like there might be different SVM, one is the one class SVM, another is the SVM with different kernels, like one Gaussian kernels or sigmoid kernels. Another is the support vector machine that uses linear kernel. Another is the support vector machine that uses polynomial kernel. It is just like, suppose there is a curve, and how to approximate this curve by linearly, or a small portion of the curve, how you will you approximate, either by linear kernel or by using some polynomials, or using say some 6-degree polynomials. Uh, and SVM also does that same thing. Like
Okay,
in
sir.
a data, in the two different classes are there, or 3 different classes. So how to SVM looks at the small portions of the classes and how to estimate that small portion, how to approximate that small portion of the of these classes, and it uses by using different kernels. So all these variations are there in this E1071 package. And now there are the some basic operations in R that I will do a quick discussion. So some examples of basic commands. Suppose you want to define one value which is 2 times square root of 5. How can you do that? So you name that value as a, then you use that. If you uh, look at the first line at the right hand side, that assignment operation a, then there is this arrow, the inverted arrow, 2 times square root of 5, and there is this help function that is very useful. Suppose you do not know what to do with a package, then what, suppose there is this under this package there is this command that's called pnorm. Pnorm is mainly mainly gives you the probability of a normal distribution. Suppose x is a normal distribution, and within the normal curve x follows somewhere. So what is the probability that x will take the value of say 5, or x probability of x equal to 6, say for example, then pnorm gives you that value. So but suppose you do not know what pnorm is, then what you can do, you can type this command help bracket pnorm, or help dot search bracket pnorm, or help dot search bracket normal distribution. Then it in the environment it shows you everything about pnorm, like what it does, how it works, and it will also show you one example also, like how to use pnorm or how to use normal distribution, how to use that package. So help is generally used not generally used when we do not know what to do with the command, with some command, or what to do with some package. Then help helps us to go through the package. Then similarly, D is a density of a curve. Like suppose you have some numbers and you want to find the you want to plot the density plot of those statistical observations. How to do it? Then D is a density. P means the probability, as I have mentioned before. Also, P norm is the probability of normal distribution. P is the probability. So, what is the probability of normal distribution x, normally distributed variable x, taking the value of 5? What is the probability? So p gives you the value of probability. R means mainly random numbers. So using this command, as you can see, rx 10 theta 10 0, what you can do, you can, from an exponential distribution with mean 10, you can simulate 10 random observations using that command, rexp 10 0. Similarly, rnorm 10 0, sorry, rnorm say 10 1. So norm 10 1 means a normal distribution with mean 10 and variance 1. And rnorm 10 1 means from that normal distribution you can randomly simulate 10 values which will follow that normal distribution with mean 10 and variance 1. Similarly, you can use R norm, then R bin, bin. R bin means R binomial. From a binomial distribution, you can also simulate. From chi-square distribution, R chi-square distribution, you can simulate. Lots of distributions are there, and from everywhere you can simulate as you want to using that command R. And similarly, Q is for quantile. So what is the for a normal distribution, what you say a normal distribution with mean 10 and variance 1, what is the first quantile, or what is the 95th quantile? That it shows here, right? Q norm 0, 0.95. So what is the, in a standard normal distribution with mean 0 and variance 1, what is the 95th quantile of the distribution? Then data creation. So how to handle with data in R? What are the different commands? So you can create data. Like if you use vectors, suppose you want to create one vector, then how will you command the vector? It is C123, and C123 gives you, say, x equal to C123. Then x is a vector which has three values, 1, 2, and 3. Then matrix is written by that. It is written here, you see, matrix C1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6 means it gives 6 values of the matrix, and then 2, 3. So 2 is the row, and 2 is the number of the rows, and 3 is the number of columns. And by row equal to 2 equal to 3, true, T means true, and F means false. So by row equal to 2, it is not necessary in this command, because if you give this 2 and 3, then R will understand how to create the matrix. Like it will take 1, 2 as the first row, 3, 4 in the second row, and 5, 6 in the third row. Uh, sorry, there are two rows, sorry. So it will take 1, 2, 3 in the first row and 4, 5, 6 in the second row. And similarly, there are different functions like list, and then there is a function like as dot list. As dot list means you can make a list. You can make a list of objects, and in that list there might be many vectors, many matrices, many data frames. You can make like that. And working directories, that is also very important in R. So R generally connects itself with one directory in your local machine. Uh, Generally, it is in the downloads, in the tab downloads, or in a separate uh, tab, in a separate corner, say in documents, or in R might make a separate corner where it loads all its work history and all the data sets and all the codes. So if you are not sure what your working directory is, you can use that command getwd. By getwd, you can find your working directory. Maybe R stores everything in your downloads. Then if you want to change your working directory, then you can use setwd. You can use setwd, and within the bracket you can give, say, within inverted within quotation marks, downloads. Then R will take that directory as download, that download as its new working directory, and it will save everything there. And in the future, when you work with a data, you can call that data from that directory where R saves everything. And how to read data? So suppose you call that data from the directory, and then how to take that data, how to bring that data to R. It is right now in your local machine, in your local directory. That might be in downloads, or that might be in documents. So what you can do, by setting your directory to that downloads or document section, you can use that command read.table. Then you can give the file name file.txt or file.csv if it is a CSV file, or if it is an Excel file, then file.sxl. And then header equal to true. Header equal to true, why? Because the columns might have names. Then you give header equal to true, or if the columns do not have names, then you give header equal to false. And it will then import that data from the download section from your local machine to the R console, and then you can work with that data. And then from after you take that data, after you bring that data to R, how will you extract the different components? So one is and these are the commands. Like suppose there is one vector, sorry, there is one matrix. Then dr is the rth row of object d, dr comma, and d comma c is the cth column of object d. So d means a matrix, so, or a data frame. drc is an entry in the matrix which is at the rth row and cth column. then length of D, if D is a vector, then length of D is how long the vector is. Suppose the vector has 10 elements, then length of D will give you 10. Then this D of D less than 20, this will extract all elements of D, a vector or a matrix, that are smaller than 20. Similarly, I put some of the examples. You can have a look at all these things from by going to that R command section and the R library and just exploring by yourself. And there are these plots. So R can, as I have said, that R can do the plots of both one-dimensional and two-dimensional plots, and also R can do the 3D plots also. The 3D plots, I mean, using the ggplot2 or ggplot, you can have the three-dimensional plots in R. And the hist, HIST, it gives you histogram. Hist bracket the data or the vector, and it builds a histogram based on those observations. Then QQ norm, it will give you the quantile plots, and you can save the plots by using the command save.as, as is shown in the at the last line of the right hand side. That using save.as, then the name of the plots, the save.as, say plot1, then it will be saved again in your working directory. So if you want to import that plot from your working directory to R, then again you have to call it. And how to call it? Just like read.table or read.plot, something like that. The next slide, please.
Okay, sir, here in data creation, working directories and files, like you have discussed set WD, where it will show the current directory where you are working, and it will
Can you please
also
be a bit
save.
louder? I cannot hear you.
Okay, sir. Sir, in data creation, you explained that set WD and get WD is a command, and through which we can check the current directory, and it will
Right.
save the data here. So how attach will work, sir?
Oh, attach. So
Okay, sir.
suppose you want to attach some files. You want
Okay,
to
sir.
attach, suppose you have, you call that data from the directory, and suppose you have all your R codes there. You have written the codes, and you have run the codes, and you have you got the result. Now suppose you want to store that result in a file, and how will you store it? So what you can do, you can use that command store, and then you can use the command attach, and so that this file will be attached to your current working directory, so that in the future you can call that file from your working directory. Or most of the times, if you do not erase your history, or if you do not erase the machine's history, then this code or these results, they are attached in your R studio, in your R console. When you open your R console, then you will see the file attached there, and you click on that file, and it will give you all the saved works and saved commands. Okay, so next slide. The regression analysis. So this is, I used regression analysis here because this is the most popular use of R nowadays, and for basic use. So regression, the general command is LM, and LM is for linear model. So it requires data to be available in the form of a data frame. So generally the data is available in matrix. So if it is not in a data frame, what you can do in R, you can write that command as.data.frame, and then give the name of that data, and it will transform the matrix to that data frame. And then it can read from that data frame this command lm, and then it can run the regression. And other types of regressions are also possible, like generalized regression, and we have that package there. It is called GLM, general linear model. And then there are generalized linear mixed regression, and there is this package called GLMM, generalized linear mixed models. So there are different commands there, but everywhere the basic principle is the same. that the data should be in a data format, in a data frame, not in a matrix. And then you use that command glm, then data, and I will show you how to give that command. I will show you in the next slides, next few slides. And then it will give you the regression results. So next slide, please. And here are some examples of plots. So the first one is a scatter plot. Just if you use the command plot x, suppose x is a vector. X is a vector one that is randomly taken from some normal distribution. Then if you use plot x, plot bracket x, then it will give you the first value. Sorry, the first plot, the first scatter plot. Then the say the histogram of temperature. Suppose you have the values of temperature taken every day during an year. So it is the daily average temperature throughout a year. Then how to do the histogram? How to make the histogram? You use that. Suppose the temperatures are stored in a vector, and the vector is named x. Then you use that command hist, H-I-S-T, hist bracket x, then it will give you the histogram. And similarly, there is the overlying graphs. You can use some commands like curve, then it will give you the graphs. Then there is the pie chart, and the command is pie, P-I-E. And if you use pie, then it will give you the pie chart. Then you can use the bar plots. There is this command called bar plot, and it will give you it will show you the bars, and lots of different commands. And within that plot command, you can use, instead of a scatter plot, you can use some lines, and then you have to give that direction. Type is equal to L. L means line, or type is equal to O. O means only the points, the scatter plot. And it will give you, according to your commands, it will give you different plots. And you can find all these commands from these packages plot and ggplot2. Next slide, please. Now we come to a real life example of our application, and by showing how R is used, I can tell you, like, and you will also understand like how R is used to solve a real life application. So in a and it actually happened here with us, with TCS. I cannot name the company because of some confidentiality. So suppose a company X, it came to us and it has this weird problem. The problem is that it makes the vaccines of a contagious disease, and the vaccine, it is made in batches. Like, it is not like one vaccine is made, then another vaccine is made. It is not done like that. It is done how? One batch of say 100 vaccines, they are made at the same time, and it is made in a very secured environment where the temperature is monitored, the air quality is monitored, the humidity is controlled, the air pressure is controlled, so that there is no contamination, there is no pollution. Otherwise, the entire vaccine will be polluted and it will be all hell will break loose. But sometimes still the still contamination might happen. How? The contamination might happen from air. Like in air, there are some dust particles, small dust particles, and they might contaminate the vaccine, the medicine. Or the person who is making the medicine, his or her garments, clothes, that can contaminate, or the finger, that can contaminate, or the medicine, that is generally, the medicine is stored in a tub, we call it a surface, we call it a plate, sorry, a biological plate. And the contamination can happen from the biological plate also. We call it surface sampling or surface contamination. So different kinds of contaminations happen. And when a contamination happens in a batch, we cannot check out of these 100 vaccines which vaccine is contaminated. It is impossible to check, and the entire batch needs to be thrown out. And that is a huge cost, because suppose one vaccine is contaminated, but for that 100 or 500 vaccines are just completely destroyed. And that is a huge cost for any company that uh, creates those vaccines. So this certain company, they came to us and asked us that, see, we have this problem and we do not know uh, what to do. So by looking at the vaccines and by looking at the air temperature, air pressure, air humidity, and all the other, we can give you all the other information as a time series, say, can you predict in advance that, well, say at 11:45 a.m. contamination might happen at this batch. There is a high risk of contamination at this batch. Can you tell us? So we took that project and we used R to solve that problem. So, uh, so what is the data model that we used? The data model that the first thing that we used that we looked at is grade A and grade B. So what is grade A and grade B? So there are two rooms within which the vaccines are made. So one is grade B, where it is a very secured environment, and there some contaminations might happen. But if the contaminations happen, then we can and if there is some alarm uh, that says that yes, there is the contamination happened now, then we can prevent it. We can prevent further contamination. That is in grade B. But in grade A, that is the utmost security, where even, I mean, very few humans can enter in this room, and where if the contamination happens, then there is nothing to do. I mean, the entire batch needs to be thrown away. So the main concern is in grade B and grade A. Our task was to reduce the number of contaminations in grade B as much as possible, and to reduce the number of contaminations to zero in grade A, because in grade A even one contamination is also not uh, permissible. So what we did, so we have the data in both grade B and grade A. We have the data of air pressure, the data of temperature, the data of dust particles, and the data of humidity. And they are all time series data. These data, all these data, they are taken for 1 year and say for each second. So some data is taken for each second, say air temperature, and some data is taken for half an hour, once in half an hour. Some data are taken once in per 5 minutes. So different time series with different frequency. And what we needed to do, so we looked at, from this 1 year's experience, we looked at different kinds of contaminations, and we found there are, say, 200 contaminations happened by air particles, 100 contaminations happened by garments, 100, say 50 contaminations happened from fingers, and all these things. So that is a, what should I say, a classification problem. So suppose you take the contamination from air. So there are 200 contaminations. So in grade B, suppose there are 5,000 observations, 5,000 time series. So out of this 5,000, there are 200 contaminations happened. So by looking at this, by learning at this problem, if a new batch comes in a new set of temperature, humidity is given, can we say that whether contamination will happen or not? So that is the problem. That is the classification problem. So what is the model one? The model 1 is predict particle count, that is the air dust particle, as contamination marker using sensor data. So what is sensor data? So sensor data is the data of temperature, humidity and air pressure. And by using them as markers, using them as regressors, whether we can predict the air dust particles, because dust particle is the main reason behind contamination. So that is the first task. The second task was predict viable count. Viable count means the number of contaminations as contamination marker using sensor data. Again, sensor data is what? The pressure, temperature, humidity and dust particles. By taking all them in account, whether we can use some classifiers to predict the contamination. So that is our task, and we did it using R. Next slide, please. So how did we solve using R? So what we did, we used so the first model one, what model one is what? Predict particle count as contamination marker using sensor data. So here we have used a linear model. A linear model is what? The in regression using R, the formula is LM. LM means linear model, and the formula is particle count, and then there is this small wave like symbol, and then as you can see, we have used temp plus press plus hum plus particle. So what does it mean? So first we have to give the formula of the linear model. In the formula, the particle count is the predicted variable, the variable we need to predict, and it is to be written in the left. And what are the markers? What are the regressor variables? They are written on the right of the wave, and they are this temperature, then this the pressure, then hum for humidity, and particle. There are some other types of air particles that we used, this particle. So by taking these four observations, these four features as regressors, we need to predict the number of particle count. And this is the command using regression, using linear regression. And it gives us some results. I'll come to the result next. And similarly, we can use a logistic regression also for the model 2. So what is the model 2? That predict viable count, that is uh, how much, I mean, whether there will be contamination or not. Viable count means 0 or 1 in grade B. Whether there will be contamination or not, or whether there will be this, the contamination will be, say, less than 3 or more than 3. So this is a binomial, this is a binary class problem. Whether 0 contamination or more than 0 contamination, or whether less than 3 contamination or more than 3 contamination, like that. And here we can use the logistic regression, and here is the formula. So the regression, the logistic regression package can be found in the package GLM, general linear model. And there it is the formula again. The formula is variable viable count, and the regressors are temperature, pressure, humidity. And data is data and family. Why family? Because since it is a logistic regression, since we want to do a logistic regression, we have to give some logistic regression family. And here we are giving binomial family. Since it's a 2-class problem, we are giving a binomial family. We could have given some other family also, say exponential family or Bernoulli family. Here we have given binomial family, and here is the command that we have used in R, and it gave us some result. And this R plot, so when it gives us this model, and here we have plotted the plotted this, the residuals versus fitted. So we are given a fitted value, the fitted value of the particle counts or fitted value of the viable counts, and what are the original values. So the original minus the fitted gives us the residual. So here the points, all these black points, they give us the residuals, the original versus the fitted. And you can see that they lie between -1 and most of them lie between -1 and +1. Generally, ideally, they should be 0 because the fitted value should be same as the original value. But they lie between -1 and +1 since it is a statistical approximation. And the red line is the fitted line that goes through the residuals. And this shows us, well, the fitted lines are, well, the fit is more or less good because all the residuals are evenly scattered over the fitted lines, and they do not go much over 1 or below -1. And they lie in a very closed region, the errors. They lie in a very closed region. Now, that is a initial study. Now we go to deep down to a finer time series study. Like this gives us a moderately good result, but we have also checked that this is a moderate result. This is not a very good result because as you can see from the right hand side text that the correlation coefficient is 0.55 and which is moderate, which is not very good. So we have to make it good. And to make it good, we need to go to some finer R models. Not to the, we cannot be happy with these basic R models. So can you please go to the next slide? Yeah. So now we go to this finer time series model. So suppose you look at temperature. So temperature is a time series model because the entire year's temperature is noted. So what we do, we plot the temperature. And there are some R package like TS. TS means time series. And another package that is called forecast. Using those packages, we select some time series windows. I mean, not the entire time series of 1 hour, 1 year, but suppose we select small windows of say 10 minutes. So 1st January of say 2018. Oh, here it is 2015. Okay. January 1st, 2015, starting from 12 in the midnight, the first window will be 12 from 12 to 12:10. Then we can use a overlapping window of 5 minutes. That means the second window will be from 12:05 to 12:15. The third window will be 12:15 to 12:25. So as you can see, this is a sliding window where each window is overlapping with the previous one and the next one for 5 minutes. So 0 to 10 or 1 to 10, then 5 to 15, then 10 to 20, then 15 to 25. We can use that sliding and overlapping window. Otherwise, we can use just non-overlapping windows also, like 1 to 10, 11 to 20, then 21 to 30, something like that. Here we have used the overlapping windows. And we have just sliced the entire 1 hour by this 10 minutes of small windows. And then in those small windows, what we did, we extract different time series features. And to extract those time series features, we have used these packages: package mass, fragdiff, terra, mgcv, forecast, and e1071. And using those packages, we have extract different features like mean, median, how many peaks are there in the time series within each of these 10 minutes window. Remember, not in that 1 hour. Within each of these 10 minutes window, how how do they behave? Like what is the skewness of the time series? What is the kurtosis of the time series? What is the periodicity? What is the seasonality? What is the trend of the time series, whether it is increasing or decreasing? All these things we can extract using those R packages, this mass, flagdiff, E1071, all these things. And these features, they serve as our data, new data. And using that data as a training data, we train on this data using some classifiers and test it on the test data, on the some new data. So next slide, please. Yeah. So in this slide, so what we did, we have extracted those features as I have told you. Then we have used those packages. Package LM for linear models for regression, and random forest. Random forest is a classifier. It is an ensemble classifier that can classify a huge data set of different varieties. And so what is the LM package? As I have again told, LM particle that is regressed on temperature, pressure, and humidity, and the data is that data set that we have mentioned. And random forest, the package is random forest. From there, the command is also random forest, and this particle is again regressed on temperature, pressure, humidity. And here we have to specify the number of trees in the forest. We specified it as 1000, and we did the result. And here is the R output. The when we run this random forest or this LM, the output is like that. This model 1 and the output is like that. You see that it gives you lots of R statistics, then F statistics, then sensors, and RMSE. RMSE means root mean square error. Then what is the accuracy? The accuracy is 99%. So it gives you all these results when you run this data. Similarly, using the random package, random forest package and U1071, I have been talking about SVM, the support vector machine. So the command is SVM. Again, count is regressed over temperature, pressure, humidity, and particle. And here we specify the kernel as Gaussian. We could have specified the kernel as linear, or as I have been telling, linear or sigmoidal kernel or a polynomial kernel also. But here we saw that a Gaussian kernel gives the best result. Similarly, we can use the KNN, the k nearest neighbor classifier, or the naive based classifier using that following command, and they give us the following result. This R console gives us the following result. When data is split into random 10-fold train and test groups using the package caret, there is another R package caret, and when we run that package caret on that data, it splits the data in random uh, 10 training and test groups. And you can take the 9 groups as training and the rest 1 group as test, and you can do the cross validation. You can do by that. And this package caret can do that by on. I mean, you do not have to do it manually. The package caret can do it. And this is the model performance measure that is also given by R. When you run those models, and they will give you the tables. And here is the accuracy, sensitivity. They are not very important for discussion, because the main important is the command and how to use those commands. And the next and the last slide, please. And this is another site that can be used by R. That is, what is the feature importance? Like, so we have, as I have told you, we have extracted many features: mean, median, skewness, kurtosis. As you can see in the at the left hand side, there are the feature names: periodicity, then mean temperature, then maximum of pressure sensor, mean humidity. Then how can we derive that which feature is important, which feature is the most important, and which feature is not? Because if the data is very large, then we need to do a feature reduction. That if not all features are important, if some features are unimportant, then we can remove those features. But which features are unimportant, we have to check that. And then there is this R package called ML bench, and another R package called caret. And there, this is the command that is written in the right hand side, if you can see. And this is the command that we define a command like control, which is train control method equal to repeated CV. Repeated CV means it goes on repeated cross validation. Number equal to 10. There are 10 cross validations, and the such method is repeated 3 times, and then it trains the model. And then train the models like that I have told you, like it can use SVM or random forest or KNN and do that, and then it gives that importance. So the command is varimp, VARIMP, varimp. So what is the importance of the model? So what are the importance of the features in this model? And when I give that command, that importance, then print importance, then it gives you the output as in the left hand side, that it lists all features and lists the importance from high to low. So here periodicity of pressure sensor is the most important one. The second most important one is mean temperature. The third most important one is maximum of pressure sensor, like that. And it goes on, and it goes to the last important feature, that is skewness of humidity. That is at the bottom of the table, and it is 0.5206. So suppose you decide that to do your computation more quickly, you will take only those features which has importance more than 0.6. So what you can do, you take only those features that has importance more than 0.6, that is features running from features starting from skewness of pressure sensor. Skewness of pressure sensor 0.6105, then auto correlation of particle sensor 0.6272. You can give that R command. R will take only those features and run your method. And it will the method will be more fast, method will be faster, and it will give more or less the similar result. So that is how we solve that problem using R. I just gave you an overview, a bird's eye view. And what I suggest you to go to Google and type different R commands or look for different R packages, and these packages, these PDFs will give you a lots of idea, like how to run these commands, and there are lots of examples also. By looking at these examples, you can have an idea. So here I stop. Now I thank you for all for to bear me for this throughout this session, and now questions please.
Thank you, Satyajit sir. I'm just seeing any question, if is there in chat box or not.
Chat box, okay, let me check.
Okay, so no question. Sir,
No
you
question.
have explained very well each and every point you have discussed, because the slide was in my hand. The control of slide was in my hand. So I
No, you
see
did
very
it very nicely.
carefully.
Thank you very much.
So as no sir, so I see very carefully each and every line, and you have explained very well. If you have in your control, so simply you see each and every point. So you have discussed very well what is a our language, and how we have used where is its weak point, like security, and if you have large volume of data. And you told that if we have there is a problem nowadays, that is big data is not a issue. A small data, if you have, then it's
Yes,
difficult
yes.
to handle. So you have told very well, sir. And one more thing, sir, that sir, from my side, one simple question, sir, that I have uh, done one Tableau, sir. Tableau, that is used for data visualization, and R is basically used in data visualization also, sir. So
Yes.
why not Python? Why R is more means they use R language for data visualization? Any reason for this, sir?
So
Data
mainly
visualization means
because
here
R is,
chart type. Yes, sir.
yes. So mainly because R is much easier to use, you know, because from a statistics perspective, I mean, just and there are so many packages in R that the visualization is very quickly you can do. I mean, in Python, maybe you have to write some codes. In R you might not write any code. I mean, it is just enough if you can run the package, and then it can be done. So R is very much user friendly from a statistician's viewpoint. R is very much user friendly.
Sir,
So
look wise also, sir.
huh?
Look wise.
Look
Like,
wise also.
if-
Look wise also.
Look wise also, look
You
wise
can
also.
have an idea if you go to if you Google it, and if you
Yes,
can go to the
yes.
Earth
Actually, sir, I did data visualization by using Tableau, and I know little. I have little knowledge about arts also. So I found that some graph is means in look wise is better than Tableau, sir. That's why I'm saying.
Okay, okay. Yeah.
Okay,
Yeah.
okay, Satyajit sir, thank you, and you, for your nice presentation. You presented very well. Each and every point was clear, and few our participant told that please share PPT in group. So
So I have
I will.
already shared that.
Yes, 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 sir. I will share, sir. Thank you,
Oh,
sir.
thank you very much.
Thank you, sir, and
Thank you
I
very
would
much,
like
sir.
to see you again in another
Thank you, thank you.
FDP.
I hope to come back again next year.
Okay, sir. Okay, sir. Okay. With more new packages.
Okay, sure, sure. Thank you, thank you. Bye.